When asked by friends and family, who are mostly non-scientists, to explain what my research is about, I find it challenging to give them an answer without causing their eyes to glaze over. Try telling your mom that you are developing a pore water sampling underwater mass spectrometer. So, in order to break down the scientific jargon, in this video I'll be discussing what mass spectrometry is, how it works, and why it is useful. What exactly is mass spectrometry? Mass spectrometry, or MS, is an analytic technique that provides elemental, structural, and isotopic information on a wide range of chemical species. MS can be used to quantify known compounds as well as identify unknown compounds in a sample. By the way, isotopes of an element are atoms with the same number of protons, or positively charged particles, but a different number of neutrons, or neutral particles. Therefore, they behave the same chemically, but have different masses. So how does MS work? Suppose a cannonball is traveling past you and you want to deflect it. All you have is a water hose, but shooting water at the cannonball won't make it change its course by much. Now instead of the cannonball, suppose a tennis ball is traveling by. Shooting the water at it will cause a huge deflection, since the ball is so light. The lesson is that the amount of deflection from a sideways force depends on the mass of the ball. Heavier balls are deflected less. If you know the speed of the ball, magnitude of the force, and amount of deflection, you can calculate the mass. This exact principle can be applied to atomic-sized particles and is the basis of MS. The next question is, what exactly happens in a mass spectrometer? The goal of MS is to produce a mass spectrum, which is a pattern representing the distribution of ions in a sample by mass-to-charge ratio, or m/z. Note, since the charge Z is usually 1, the m/z spectrum is usually referred to as a mass spectrum. Obtaining a mass spectrum involves a 4-step process. 1. Introduction of the chemical compounds into the mass spectrometer vacuum system. 2. Ionization of the sample chemical compound. 3. Separation of the compounds based on the m/z of individual ions. And 4. Detection of the ions, whose signals will be used to create a mass spectrum. The first step is sample introduction. Mass spectrometers must operate under a high vacuum. Using membrane inlets is a common method to introduce samples from the external environment into the instrument. Here, gases dissolved in a sample liquid can pass through the membrane and enter the vacuum of the mass spectrometer to be analyzed. Once in the mass spectrometer, the first requirement is to ionize target atoms and molecules through the addition or removal of electrons. A popular technique is electron impact, in which electrons produced by a heated filament bombard sample molecules. As this beam of electrons collides with sample gas molecules entering the vacuum, the molecules are broken apart into fragments, forming positively charged ions. This process is known as molecular fragmentation. Measured fragmentation patterns are highly characteristic of each molecule. The charged ions are then accelerated as a beam of ions into the mass analyzer. The next step is ion deflection. This process occurs in the mass analyzer, which can be considered the heart of the mass spectrometer. A common method is to use electric and/or magnetic fields to separate sample ions so that only ions of a certain mass-to-charge ratio will reach the detector. Lastly is sample detection. In this final task, the different mass-to-charge signals are scanned across the detector, and the ion current exiting the mass analyzer is recorded as a function of time. Following detection, the measured ion currents are output to a computer and a mass spectrum is generated. Perhaps the most important question is, why is mass spectrometry useful? MS is one of the most versatile analytical methods currently available. It can analyze a range of species using a single sensor. Mass spectrometers are used by physicists, chemists, biologists, physicians, astronomers, geologists, so pretty much every type of scientist. They are routinely used to monitor nuclear facilities, detect environmental pollutants, and diagnose drug abuse. They have also been used to explore outer space as well as deployed in the ocean. In a follow-up video, I will focus on the applications of MS. In particular, I will discuss the emerging field of underwater mass spectrometry. So thanks for watching, and I hope you learned something useful. Feel free to visit our website or to contact me via email. See you in the next video.